So let's take another look at sketching parametric equations, or the graphs of parametric equations. And I want to relate this to the Cartesian graphs. So for example, let's say we've got our x versus t graph here. So this should be x, and this is t, and then this is our y versus t graph here. And then we want to sketch x versus y. So, well, one way we can do that is make a table of values. So for our x coordinate, let's see here, let's just estimate when t is -1, it looks like x is, let's see, that's 2.550. It's going off the end here, maybe -4. And let's see, when x is 0, or I'm sorry, when t is 0, x looks like it's about, maybe about 1. When x is 1, go up and over, looks like, or I'm sorry, when t is 1, x is about 2. When t is 2, go up and over, we're at about height 1 again. When t is 3, go up and over, we're about height 5. Then do the same thing for the y graph. So when t is -1, we're down here at about -4 again. And then when t is 0, we're at 0. When t is 1, we're up here at about height 2 approximately. When t is 2, we're back to height 0. And when t is 3, we're probably back down at about -4. So now we can graph our xy ordered pairs. So our -4, that's actually off the graph, but when t equals 0, x is 1 and y is 0. So that'd be right here. That's t equals 0. When t is 1, we're at the point 22, so it's right there. When t is 2, we're at 1, 0. So we're back at this point here. And then when t is 3, we're at 5, -4. So 5, -4 would be about down here. So, and what we see is that our x increases, it maxes out at about t equals 1/2. And it's up at about height 2. So we're going from, and let's see, this is t equals 0, 2, and then this was t equals 3. So we start here, we are going up to t equal 1, which is at 2, 2, and then back down. Well, it's not going to come in a straight line here. Notice that your x is increasing really fast here, and then in between here it's increasing slowly. So it's going to go up fast. Let's see, no, your x is going to go to the right fast and then more slowly to come to this point. So it would look something like this. And then your x decreases a little bit and then goes back up. So it's going to come back to the left and then go back to the right. So something like this. And then if we had that point -4, -4, that would actually be way down here. And so this guy would come down to that point. So this is really just a loop. That's the graph of a loop there. And the direction of increasing t is going to tell us how we're going around the loop. Now you may be saying, well, how did I know it went like this and not like this? Well, there's a little bit of leeway there when we're sketching from the graphs and we don't have the equations. But if you're in doubt, plot more points. So take t is 0.5, 1.5, and 2.5, add some more points to your table, and then you should get, points that are out here. So now the actual equation or actual problem in your homework is a matching problem. So let's take a look at a matching. So here the numbers belong to the x of t and y of t graph. So this column is your x coordinate, and this column is your y coordinate, and then the parametric graph is over here. So this is your x of t comma y of t. And we want to match those up. So we can do a little bit of this by process of elimination. So if we look down through here, here I see, as you follow this curve around, you can see that your x coordinate, so your left and right, is oscillating between -1 and 1, and then your up and down is also oscillating between -1 and 1. So x and y are both oscillating between -1 and 1. That's what's going on here, and it's it's multiple times. So here our x coordinate does start at -1, goes up to 1, and back down to 1. But our y coordinate only goes from -0.5 to 0.5. So that's definitely out. Here we see that our x coordinate starts over here at -1, increases, decreases, and then increases. I'm paying attention to right, left, right as I go around the curve this way. And our y coordinate here just goes up to this point, and then y comes down as you're going around the curve. So not nearly as much oscillation there. And then here we've got this diamond-shaped graph. There, y only goes between -1/2 and +1/2, and x goes -1 to 1. So that, I think, might nail it down to the first graph, because we look up at this graph. Here's our x coordinate here. X, this is again t versus x, and that goes down between -1 and 1, but then our y graph, this is y versus t, y only goes from -1/2 here to +1/2. So let's look at the rest of those and see if anything else goes -1/2 to +1/2 in the y. So this is -1 to 1, -1 to 1, -1 to 1, -1 to 1, and then the last one also -1 to 1. Okay, so we got one of them down. So this guy right here, C, has to go with 1. So 1 goes with C, and we'll cross that guy out. So we got that one set. How about the multiple oscillations here in x and y? So I see here our x values only go down to 0. They go between 0 and 1, so that guy's out. Here our x values only go down to about -0.25. They go up to +1, so that's out. That doesn't match the first one. Here we've got lots of oscillations between 1 and -1 in the x, and lots of oscillations between 1 and -1 in the y. And I think, if you look at A, B, C, D, E, F, that's the only graph that has lots of oscillations. So I think that 4 goes with A. So that's matched up. So let's see here. D, graph D, we've got only negative x values. The y values go from -1 to 1, but the x values are negative. So we're looking for an x graph that's always below the t-axis. So this one's positive, this is some positive and some negative. Again, same thing. 6, that's the only one. It goes up to 0, down to -1. This is the only one where the x coordinate's negative. And then your y coordinate is always increasing. So let's see if that fits with this guy. So your x coordinate, it increases and then decreases. Yep, that fit with our x versus t graph. And our y coordinate, as you go up this graph, is always increasing. It stops for just a second there. So D, got that one set. That has to be with 6. How about E? See here, our x coordinate just goes between 0 and 1. We've got no negative x values there. So look at our x graphs, and our y graph goes between -1 and 1. So x graph is only positive. I think that's got to be 2. I think we used up 1, didn't we? Yeah. So I think that's got to be 2. X is positive, goes up to 1 and back down to 0. Your y graph starts at 0, up to 1, down to -1, and back to 0. So I think that goes with our ellipse, which is E. And you can see here that as you go around the ellipse, starting from here, your x increases going to the right and then decreases going to the left. Your y value goes down, up, and then back down. And that's what happened here. Up, down, up. Oh, it must be going the other way. Up, down, and then back up. So we must be going this way around. So x value increases and then decreases. But that one's taken up. So now let's see, what do we got left? So we have got this loop here. So we want an x value that goes to the right to about here, and then to the left there, and then back to the right. So that would be up, down, up. And then your y graph goes up to here and then down. So up, down, up, and x. I think that's 5. X is going up, increasing to the right, down, decreasing to the left, up, increasing to the right. Your y value is going up and then back down. So 5 has got to go with B. And then that means that this little shoelace here, F, has to go with 3. And let's see if that makes sense. So our x is decreasing, increasing, decreasing, increasing. And y is going up, down, up. So this is going to be left, right, and then y is up, down, up. So let's see here. So let's see if we came in this way, left, right, and your y is up, down, up. Yep, that works. So I think we got them all. So you should be able to do something similar with web assigned problem number 4 and the matching there. You should be able to do some elimination. Why don't you give that one a try?